Hello everyone, welcome to my lecture video 6. Today we'll start logarithmic differentiation. I hope all of you have watched lecture video 5 and all of you have also done homework 10. So now let's do the materials for homework 11. So we'll start today natural logarithmic function. Okay, so what is a natural logarithmic function? So a natural logarithmic function can be defined as a natural logarithmic function is denoted by this symbol lnx. So we use this symbol to denote the natural logarithmic function lnx, and it is defined as lnx equal to integral from 1 to x 1 by d dt. So this is the definition of a natural logarithmic function. So I define a natural logarithmic function lnx as this integral. I integrate from 1 to x 1 by d dt. So this whole thing, whatever value I get, so that is denoted by this symbol lnx, right? Okay, so now the domain of this function, the domain of lnx is 0 infinity. So the function, this function lnx, it is only defined for positive values of x. I cannot put any negative value of x here. So the domain of lnx is 0 infinity. Now let's try to see how the graph of lnx looks like. So I'm drawing the graph here. So this is how the graph of lnx look like. The graph of lnx, it cuts the x-axis at the point 1. There is a special number which we denoted by e, the letter e. At the value of at the point e, the lnx takes value 1. At 1, it takes value 0. So this is how the graph actually looks like of lnx. So if I take a value of x between the numbers 0 and 1, the value of lnx is negative. If I take a value of x which is greater than 1, the value of lnx is positive. There is a special number called e. At the point e, the value of lnx is 1. So if you draw horizontal line here, it will cut the x-axis, and again if you draw vertical, it will hit at the point e. This is a special number e. So e is the special number at which the graph of lnx yields value 1. Okay, so this is the graph of lnx. You have to just remember it. So the graph of y equal to lnx, it cuts the x-axis at the point 1. At the number e, it takes value 1. Okay, and it is defined in this way: lnx equal to 1 by x 1 by d dt, and its domain is 0 infinity. Now let's try to understand what are the properties of lnx and why it is so important in calculus. So now let's study the properties of ln x. Properties of ln x. Okay. The first property of ln x is ln xy is equal to ln x plus ln y. So this is a very important property. So natural logarithm, if you have two numbers x and y, and if you apply the natural logarithm into the product of them, so it will be equal to the ln applied to the first number plus ln applied to the second number. So this holds for any number x and y. If you take any two numbers, if you apply ln right to the product of these two numbers, it will be equal to ln of the first number plus ln of the second number. Due to this important property, and there are several other properties that I am going to list them below, it helps to reduce complicated mathematical formulas into very simpler ones, and that is why the natural logarithmic function is so important. And moreover, it is often called the catalyst of mathematics. So catalyst, in the way, I think those who have studied chemistry, you know that catalyst is a substances which sort of increases the rate of a chemical reaction. So the natural logarithmic function, in a way, it helps us to do differentiation, integration much easily. So it helps us to do mathematical analysis much easily because of its various properties that we are going to study. Because of that, it is often called the catalyst. Okay, so this is the first property. If you take any bigger number, ln xy, it is just equal to ln x plus ln y. Right. So number 2 is ln x by y. What is that? So ln applied to the quotient of two numbers, this is equal to ln x minus ln y. Right? So let me illustrate these two formulas with some example. If you take, for example, so you want to calculate ln, say 100 times 100. So you want to calculate that. ln 100 times 100. It's a very big number, right? But you see that using this property, since you know that ln xy is ln x plus ln y, you can easily write these as ln 100 plus ln 100. So you see that your the whole thing has got now reduced to the sum, because sum is always easier to do compared to product. So that's why this formula is significant, the first one. In the same way, you can reduce a division to a subtraction using this formula. ln x by y equal to ln x minus ln y. The third formula is far more important. If I have a power, right, say x, the power is r, then this is equal to r ln x. So if I have ln x, the power is r, then the power can be taken out. So this formula is very important because it is often very hard to compute out powers. For example, if you want to say compute out, say 10 to the power 1000, it's a very big number, right? You want to calculate 10 to the power 1000. Now if you apply ln, what happens is that 1000 comes to the front. Using this, the power always comes to the front. So I can write this as 1000 ln 10, and this is a very small number. So it has reduced the power to a product, because product is easier compared to powers. So it has reduced the power to a product, and again sum is again easier compared to product. So in that way, these three formulas helps us to reduce very complicated formulas into very simpler ones. The first one tells you that the ln applied to the product is equal to the sum of the ln x by y equal to ln x minus ln y. The third one, ln x power r equal to r ln x. Okay. Now let's try to find out what is the value of derivative of ln x. To find out the derivative of ln x, just recall what is the definition of ln x. So how did we define ln x? Okay, so how did we define ln x? So we defined ln x as an integral, right, from 1 to x 1 by t dt. Now tell me, so if the value of ln x is integral from 1 to x 1 by t dt, then what will be the value of ddx of the derivative of ln x? The derivative of ln x will be equal to the derivative of integral from 1 to x 1 by t dt, right? Now, so this is an integral, and outside that I have a derivative. So I have a integral, outside that I have a derivative. So what does that mean? So there is a theorem called the fundamental theorem of calculus, which you have studied in test 3. This theorem tells you that differentiation and integration, these are reverse processes of each other. So that means if I integrate first, then if I differentiate, I get back the original function. So exactly that happens here. So observe that here I am first integrating from 1 to x, and then I am differentiating with respect to x. So that means using the fundamental theorem of calculus, I will be left with the original function, but with t replaced by x. So I will be just having 1 over x. So this is a very, very crucial result. ddx of ln x is 1 over x, right? So the derivative of natural logarithmic function is 1 over x. Now, since differentiation and integration are reverse processes of each other, so if I differentiate ln x, if I get 1 over x, if I integrate 1 over x, I should get back ln x because they are reverse processes. So if I differentiate it, if I get that, so if I integrate this, I should get back that ln x. So this is the next result, that integral of 1 over x dx, this is ln absolute value of x plus c. So why did I put absolute value? Because the domain is negative. The domain of ln x is always positive. So whatever x I should put, I should always put some bar so as to make the domain positive. So integral of 1 over x, so it is not that much compulsory to write those bars, but it is good to write the bars just to show that I am trying to make the domain of ln x positive, right? So integral of 1 over x dx, this is equal to ln absolute value of x plus c. Okay, so this is the next very, very important formula. So these 5 formulas, in addition, these are the easy ones that we already have studied, that ln e is 1, the value of natural logarithm at the point e is 1. So what is e? The definition of e is that e is a number at which the value of ln is 1. You can define e in that way. Okay, and then the last one is ln 1 equal to 0. So at the point 1, it takes value 0. So these 7 properties are going to play a very crucial role in all the problems that we do. Okay, so these 7 formulas have to be quoted to memory, and using these 7 formulas we will now do the problems. So let's take the first concept, which is differentiation of functions of ln x. the first exercise of natural logarithmic function in note 9. Okay, so differentiate the following functions of ln(x). Differentiate the following functions of ln(x). Okay, so let's take the first one. Y equals to ln x cubed plus 1. So I am asked to differentiate this function. So how will I go about it? So dy dx equal to, so observe that there are two functions here. The outer function is ln x and the inner function is x cubed plus 1. So this is the outer function, this is the inner function. So we have to use chain rule. So the outer function is y equal to ln x and the inner function is y equal to x cubed plus 1. So what is the derivative of ln x? So I think it's not visible. Let me write it here. So here the outer function is y equal to ln x and the inner function is y equal to x cubed plus 1. So what is the derivative of ln x? So the derivative of ln x, that is dy dx, is 1 over x, and the derivative of x cubed plus 1 is 3x square, right? So by chain rule, this should be derivative of outer function at inner function. So the outer function is ln x, its derivative is 1 over x. So at inner function means it should be 1 over x cubed plus 1 times the derivative of inner function, that is d dx of x cubed plus 1. So it should be 1 over x cubed plus 1 times 3x square. So this is how you do it. It's very, very simple. The outer function is ln x, so its derivative is 1 over x. So derivative of outer function at inner function. So 1 over x cubed plus 1 times the derivative of inner function. So it will be 1 over x cubed plus 1 times 3x square. Okay, now let's take the next problem. Okay, the next problem is y equal to sin x, ln sin x. Okay, so how do you find out the derivative of this? So here the outer function is ln x, right, and the inner function is sin x. So dy dx is, so derivative of outer function at inner function. So the derivative of ln x is 1 over x, but we have to evaluate it at the inner function. So it will be 1 over sin x times the derivative of inner function, that is d dx of sine x. So it will be 1 over sine x times cosine x, right? And you all know what is the value of cosine x by sine x. It is cot x. Now let's take the next problem. The next problem is y equal to ln x plus square root of x squared minus 1, right? So here, what is the outer function? The outer function is ln x and the inner function is x plus square root of x squared minus 1. So the outer function is, I'm just writing it down here, the outer function is ln x and the inner function is x plus square root of x squared minus 1, right? Now what is the derivative of ln x? The derivative of ln x is 1 over x, right? And what is the, so how the chain rule goes? We have to first of all find out the derivative of outer function, that is the derivative of ln x, which is 1 over x, but we have to evaluate it at the inner function. What does that mean? That is, we have to replace this x by whatever is inside. So it should be 1 over x plus square root of x squared times, we have to then multiply whatever this with the derivative of inner function, that is ddx of x plus square root of x squared minus 1, right? So the first part will be as it is, 1 by x plus square root of x squared minus 1 time ddx of x plus square root of x squared plus 1, this is equal to ddx of x plus ddx of square root of x squared minus 1, right? Now ddx of x is just 1 and ddx of square root of x squared plus 1 minus 1 is half. So again we have to apply chain rule here. So I am trying to find out derivative of square root of x squared minus 1. So here the outer function is square root of x and the inner function is x squared minus 1. So here again, now to find out ddx of square root of x squared minus 1, we have to apply again chain rule. So this time, now while finding ddx of square root of x squared minus 1, my outer function is square root of x and my inner function is x squared minus 1, right? Now what is the derivative of square root of x? It is half x half minus 1. This is the derivative of square root of x. Now half x half minus 1. So half minus 1 means minus half. Now half x minus half can be written as half 1 by square root of x. So this can be written as, so half x half minus 1 means half x minus half. Now x minus half means what? This is 1 by square root of x. So the value of the derivative of square root of x is 1 by 2 square root of x. This is the derivative of outer function. It has to be evaluated at the inner function, and the inner function is x squared minus 1. So it should be 1 by 2 square root of x squared minus 1 times the derivative of inner function, which is x squared minus 1. So ddx of x squared minus 1. Okay. Now if you just try to simplify it further, I'm showing this to you. Now if you try to simplify this further, what you will get is, this is 1 by x plus square root of x squared minus 1 plus, so ddx of x squared minus 1 is 2x, so it should be 1 by 2 square root of square minus 1 times 2x. Right? Now finally this 2 and this 2 will get cancelled, and you can write down your final answer after simplification as 1 by x plus square root of x square minus 1. Now if you simplify this, you have 1 plus x by square root of x square minus 1. So you can write this as square root of x square minus 1 plus x by square root of x square minus 1, right? Now you see that x plus square root of x square minus 1, here I also have x plus square root of x square minus 1, so they get cancelled, and I will be just left with 1 by square root of x square minus 1. This should be my answer. So take it down. So this is how we are going to do it. Okay. So now let's do the next problem. Okay, so the next problem is y equal to ln 10x whole square. So how to do it? So here, what is the outer function? The outer function is, so there are three functions here. You see, at the outermost, I have x square. Inside that, I have ln x. The innermost is 10x. So we have to apply chain rule twice. So first of all, what is the outermost function? The outermost function is x square. So what is the derivative of x square? The derivative of x square is 2x. But we have to sort of find out the derivative of x means the derivative of outer function at inner function. So it should be 2 times what is inside, right, which is that is ln 10x, then derivative of inner function. So here dy dx is equal to 2 times whatever is inside, because the derivative of x square is 2x, so 2 times ln 10x times derivative of ln 10x, right? Now here, while finding the ddx of ln 10x, I have to apply chain rule. So now the outer function is ln x and the inner function is 10x. Now, and the derivative of ln x is 1 over x. So it should be now 2 ln 10x So since the derivative of ln x is 1 over x, so x is x replacing it by 10x, should be 1 over 10x times the derivative of 10x. Now what is the derivative of 10x? It is sec square x, so it should be 2 ln 10x times 1 over 10x times sec square x. Okay, now let's take the next problem. Y equal to ln 1 over x, right? So this is very easy. So what is the outer function here? The outer function is ln x and the inner function is 1 over x. So dy dx will be derivative of outer function, which is ln x is 1 over x, so it should be 1 by x times the derivative of inner function is 1 over x, so ddx of 1 over x. Now what is so 1 by 1 over x, so dividing one fraction by another fraction is equal to multiplying the top fraction with the reciprocal of the second, so the bottom gets flipped, so it should be 1 times x, so just x times what is ddx of 1 over x, so 1 over x can be written as x power minus 1. Now by power rule it should be minus 1 x minus 1 minus 1, so it should be x times minus 1 times x minus 2, so it should be minus x times 1 over x square, right? So x times 1 over x square, so it should be minus 1 over x. Okay, so now let's take the next problem, the last one. Okay, so now we are trying to do number 6, which is y equal to tan of ln ax plus b. Okay, now so here again there are three functions. The outermost function is tan x, then I have ln x, and the innermost is ax plus b. So first I want to apply chain rule dy dx. So the outermost function is ln x, tan x. So what is the derivative of tan x? So the outermost function is y equal to tan x. Inside y equal to tan x, I have y equal to ln x, and then I have y equal to ax plus b. These are the three functions I have. Okay. Now, what is the derivative of tan x? The derivative of tan x is sec square x. So I should have to write sec square in place of x, what is inside, ln ax plus b times whatever is in the inside, that's derivative. So ddx of ln ax plus b. Now here again you see there are two functions, so I have to again apply chain rule. The outer function is ln x and the inner function is ax plus b. So it should be sec square ln ax plus b times, the outer function is ln x, so its derivative is 1 over x, so it should be 1 over ax plus b times ddx of ax plus b. Right? Now ddx of x plus b is just a, so it should be sec square ln ax plus b times 1 over ax plus b times a. Okay. So this is the end of the chapter on natural logarithmic function. So now you are in a position to do your homework 11. But before I end this lecture, I want to discuss some problems on homework 11, so as to make it easier for you. Okay. So in your homework 11, there will be some problems like this. Express the given quantity as a single logarithm. Let me show you some example, and then I think you should be able to do the remaining. So now we are discussing homework 11. Okay, so now there will be some problems like express the given quantity as a single logarithm. Okay, so for example, let's take an easy one first. For example, I have this ln 7 plus 3 ln 2. Now to do all these problems, you have to basically remember these three formulas that we discussed. Ln xy is equal to ln x plus ln y. So ln applied to the product of the numbers is equal to the ln of the first number plus ln of the second number. Ln x by y is equal to ln x minus ln y. Ln x power r equal to r ln x. These are the three laws that you need to remember. Now you see, here I have ln 7 plus 3 ln 2. Now first of all, using this power rule, observe that if I have r times ln x, I can take this r to the power of x. I can write this as ln x to the power r. So using that, I can write 3 ln 2 as ln 2 cubed, because this 3 can be taken to the top, just like this, just using this formula. Ln x to the power r equal to r ln x. So reversibly, I can write r ln x as ln x to the power r, just like this. 3 ln 2 can be written as ln 2 cubed. Okay. Now you see, now I am going to apply the first law. Ln x plus ln y, this is equal to ln x times y. So ln 7 plus ln 2 cubed can be written as ln 7 times 2 cubed. Right? So this is how you need to do it. So you need to express this quantity as a single logarithm. Right? Now let's take another formula. One third ln x plus 2 whole cubed plus half ln x minus ln x square plus 3x plus 2 whole square. This is what I need to do. So ln 1/3 ln x plus 2 whole cubed plus half ln x minus ln x square plus 3x plus 2 whole square. So first of all, you see I have ln x minus ln x square plus 3x plus 2 whole square. So I can write this using this property, ln x by y equal to ln x minus ln y. So I have ln x minus ln y. So I can write this as ln x. The first part will remain the same. The second part, I can write this as ln x by x whole divided by x square plus 3x plus 2 whole square. Now you see I have half outside ln x. So using this property where something that is outside can be taken to the power, I can take half to the power of this. So I can write this as 1/3 ln x plus 2 whole cubed plus ln, I can write down half means, so if I have a power half, that means I am ultimately taking square root. So I can write this as square root of x by x square plus 3x plus 2 whole square. Same thing happens here. So I have 1/3, so it can be taken to the power. So it becomes ln x plus 2 3 by 3, right? Because plus I had ln square root of x divided by, now square root of x square plus 3x plus 2 whole square. So square root and square will cancel each other and we'll left with just x square plus 3x plus 2. Finally, I see again, lastly, I have ln this plus ln this. So ln, using the first property, ln x plus ln y equal to ln xy. So ln x plus ln y, it can be written as ln x plus 2 times square root of x divided by x square plus 3x plus 2. And because here 3 by 3 is 1, right? So this is the result. So we have combined this whole thing into a single logarithm. So this type of problems will appear in the homeworks. So the problem that will be in your homework for homework number 11 will be, you will have some problems on like this, converting a quantity into a single logarithm. You will have some problems on finding derivative of ln x. So if you have any problems during the homework, you can contact me through Zoom. So you have to request a Zoom meeting. I'll provide you the ID and the password for Zoom meeting. So other than that, you should be good in doing homework number 11. So all of you do homework number 11. In my next lecture, I'll be doing, I'll give you the materials for homework number 12. That is a natural exponential function. Okay. Till then, goodbye.